Hello, everybody. I hope I can get through this. The software isn't working well enough to do some things I want to do, but I'll try. What I want to do right now is do an example of homework 8. Homework 8 is taking two uh, large integers and adding them together. I'm going to do it with the example I have here. My first integer is 9. I think that's an 8. 7. I think that's a 6. You have to excuse me. I had to bring these, make these smaller so they would fit. So that's 9, 8, 7, 6, 2. And the other integer I'm looking at is 2, 3, 5, 6. Now, how do I know that? The beginning of each integer is pointed to by the node that last points to. So if we have last, you look at the node it points to, and you look at the forward pointer on it. The forward pointer on it points to the first digit of the number on the left-hand side. So this is 98,762. And over on the other one, that's 2,356. Basically, what we're doing is you follow the forward pointer when you want to go from left to right. You follow the backward pointer when you want to go from right to left. Now let me bring this down just a little. So I'm going to begin. There's a line in, I should say that there's a method, reset back position. First thing you have to do is do that for the new sum, the answer. So I am resetting the back position. I have last is pointing, it is null. There's nothing there. And now I'm ready. I use the function, this is not the one, it's the next one. It's the one under here, if I can find it. There it is. I use the function not add to front. Oh, it was on the other one, pardon me. I use the function get prior to get me the last digit of these. Now, get prior has another item called finished. And what that is if it turns out that you've gone all the way through the integer and there's no more, you're at the beginning, then finish will be turned on. So we look. I send in not finished first. I send in false for finished. So if true, if the current back position equals null, it does. Current back position equals last. Remember, what we had here set our current back position to null. It didn't change last. It just changed the current back position. So if the current back position is null, we now have the current back position, which I guess I could put here. You can see that. And that is, at this point, pointing to last. So I do that, and then at the end of that, I get the digit that current back position val. So I get the 2. So again, this changes current back position. This gives me the digit that it's pointing to. Now I do that on both of these. So I have a current back position here too. And it's pointing at this point now, after we call this get once, it's pointing right to where last is pointing, and we bring back its value, which is 6. So now I have 2 and 6. I add those together with the carry. Before I went into this loop that I'm doing, I set the carry to 0. So I have 2 plus 6 is 8. And there's no carry, so the carry is made 0. And now I create a new node. I put 8 into that new node. And now I have to connect it up. That's the last item at this point. So I change the null of last by having it point to this last item, the only one there at this point. So it's pointing down to there. Then I had to do something with forward and backward. Well, this is going to be a little tough, but I'll try to do it so we can see it. I think I need this one. I'm basically going to have each of them point to itself. And I'm going to have the same thing here. I hope I am anyway. Let's try to have this point to itself. So that's the first one. We finished adding one digit. Now what I'm going to do is I'm going to move that. I'm going to try to move that down. So I'll insert some empty space here. And then I'm going to copy what this is at this point. I'm going to copy it up to there. So I'm ready to do the next step. Well, the next step, we go back to here. We call prior again. Prior says, if not finished, it's not finished. If the current back position equals null, it doesn't equal null. Change the current back position to the backward of the current back position. So we change this. It's no longer pointing there. It's pointing to where the backward of that points to, so it's down to there. And we're going to do the same thing over here eventually. We're going to point it to where it's pointing. And now I'm going to pick up in the calls the numbers 6 and 5. I'm going to add the 6 and 5 in the carry. Adding the 6 and 5 produces 11. So the carry is 1 and the digit is 1. I put the 1 in as the digit, and then I have to connect up items. Well, first of all, is this the last or not? It isn't. Remember that we do our addition from right to left. So 1 is going to point to 8. 1 is the forward, so the forward pointer of 1, the new item. Oh, you don't really have to do this because there's a function for it over here. And that makes life much easier, I'm sure. If I can force it to come back. Right, and it's the other one. I just call add to front. and add the front takes care of everything for me. What it does is it has the new item I put in there point to the old item. So it points to here. The back has to point the other way, but there's only one other way, so it's going to point to the same thing at this point. So there's not going to be a difference there. And the same thing is going to be true for these. That's going to go away. That's going to go away. And me, it doesn't want to go away. All right. The forward pointer is going to point to here. And the backward, and I'm going to make that, I make my forward pointers green if I get a chance. So I should make this one green also. And my backward pointer, this one here, I'll put in orange. And then, of course, I have to have one more backward pointer, this one here, which is also in orange. Now let's pause for a minute. What have I done so far? I've added the ones digits and the tens digits. The ones digits were 2 and 6. They produced an 8. The tens digits were 5 and 6. They produced an 11, which gives me a 1 with a carry of 1. Now, if you look at this number, the sum, which is what this is, it starts to wherever the backward of last is pointing. So it starts at 1, and the number so far is 1/8. Now again, I'm going to fill in a little of the hole here. I'm going to move that down and copy it so I can make the change in it in a minute. So now I'm ready to fight the third digit. So let's go back up. I go back to get prior. This is now going to be pointing to where this is pointing. So it's going to go way down to here. That's up there. This one is going to point to where that's pointing to. So that's here. Now I can take this up and hopefully point it the right place. So the two get priors will do that for me, and they will get me 7 and 3. I add the 7 and 3, and I add the carry. So now I have 11 again because there's a carry of 1. So I add the front. Adding the front gives me a 1 here, and I've got a carry. That is the new front. So that means that this has to point to what was above it. So right now I have to take this, and it has to point to the backward has to point to the 1. Let me make sure that the 1, no, this has to point up to here. And that didn't work very well. So let me get rid of that and do it again. So I've got it set. and it's got to point up to, let's see, its backward points up to the last one, the previous one that was backward, at the top there. And this forward now points to the 1 that is here. And of course, we have to change the backwards. This backward still points to 8, to 1, but this backward now points to here. Now let's see if the number makes sense when we do this. We begin with where, oh, I did one thing wrong there, pardon me. I didn't give you the forward of this one. I put it in the wrong place. No, I didn't, pardon me. What I did was I think I put this in the wrong place. Let me see, I want 1 going forward to here, and I want this going forward to 8. So that should go to there. So it should go here. And so far that gives me the 1, 1, 8. And now the backward should go in the other direction. So the backward of this should go to the beginning, which now is here. And that backward should go up to here. So this backward should change color, among other things. So this backward should go from here. Now I can just change the color. So it goes up to here. And now let's see what's happening. See if it does make sense. I think I still have one more pointer to change. I have to change this one to point to here. Yes, it's 1. The forwards go, I didn't have the last forward in there, pardon me. So let me put the last forward in. This goes to there, and that is green. Now let's look at the forwards again. The top of it is supposed to be that you look where last is pointing, and you go to the backward of last. Well, the backward of last is the 1. So we have 1, 1, 8, which is what we're supposed to have. Now, if we're going in that direction that way, this one ought to change colors, by the way, it should be green. Let's see what we should get. We have to go around in the other way of the circle. So it looks to me like that's what we're doing. We're going around the 1 that's at the top, points to the next digit 1, points to the next digit 8. And the last digit 8 points to the first digit. Now that's complicated, I won't deny it. But the point is, most of it you don't have to do. Add to front does all that for you. Look at all these areas over here where it changes this, changes that. It creates the node. All that's done for you. All you have to understand is that you use the priors to get the digits, and you use the add to front to add the digits into the sum. Now, when you end, there's one little quirk. You might have a leftover carry. And if you do, you have to add that to the front. You will also have to handle the finished problems. If one of these two is going to finish before the other one, the top one only has 4, the left one only has, the right one has 4, the left one has 6. So after the 4th digit, you're not going to have a 5th digit from the right one, unless it's a carry. Well, you'll have a carry maybe, but you won't have a digit. So your program should check to see if it's finished, if that particular addend is finished. If it's finished, then the digit from that particular addend is 0. So there should be some kind of if statement inside your loop that says if this one's finished, the digit is 0. Or if that one, and it might be one of them's finished, maybe both of them are finished, and you have to check to see, and then you're going to get out of your loop. So I would suggest that is the way to think about it. What I think you should do now is continue the example from here. I will put this out in a few minutes. I'll put out the Excel file. I'll put out these 2 files here that I've been using on the side. Take a look at it and see if you can follow it. Now again, you don't have to do all the rearranging of the pointers. That's being done by the functions, the methods. That's the value of having the higher named methods. All you have to do is basically reset and use a lot of get priors and add to fronts. Your actual lines are probably about 1 or 2 lines. Well, you've got the ifs for the finished, and you've got the addition of the digits and the carry. All right, so that's where I am now. I'm going to finish right now and post this and hope that it helps you. I suspect I may have to do some more of this, but that's okay.